So hi everyone. So that talk is about Coursier, which is a library and a bunch of tools to manage dependencies. So in that talk, I'd like to first discuss what were the motivations for writing it. Then I'd like to discuss what are the goals for its 1.0 final version, which hopefully should happen in a matter of weeks. And then I'd like to discuss the kind of applications that can be built on top of it. So about me, I contributed a bit to Shapeless. So I'm the author of Coursier and also of Jupyter Scala that I'm talking about tomorrow. And I'm working at a company called tid.tv, which does native video advertising. So Coursier is a library to manage dependencies, and roughly this kind of libraries consists in two big components. That is, we have one, on the one hand, it works a dependency graph. That is, it goes from one dependency to the other while at the same time reconciling versions or handling exclusions, this kind of things. And on the other hand, it downloads and caches things, that is metadata and jars. On the one hand, we have basically some data domain modeling that Scala is quite well suited to handle. And on the other hand, we have some I/O and cache management. And so one of the goals of Coursier was to have a library to manage dependencies that clearly separates these two concerns. And the aim of that is to make it easier to add features to both of these two things. That is, on the one hand, for the domain modeling stuff, one of its goals was to have a really reproducible resolutions. That is, reproducible resolutions across platforms. That is not something that would check some system properties under the hood and behave differently depending on what it finds here. That is, the goal of Coursier was really to be referentially transparent. Then, on the other hand, about the downloading and caching stuff, one of the goal of making that better was to first enable parallel downloads. That is, being able to download metadata and jars in parallel. Also, one of the goals was not to have, not to require some cache-wide lock. Unlike, I guess we all run into the global locks in SBT, and one of the goals of Coursier was not to require this kind of locks. Also, when we tweak this part, we can also have some, and we can also manage to have an offline mode. Because we never know if the one of SBT really works. Basically, Coursier consists in at the core, the very core of Coursier is a library. That is, it consists of two models corresponding to the two concerns just before. So the first one is the core model with the domain modeling stuff, and cache handles all the caching and downloading stuff. And so this very core is already has a few early adopters. So for example, libisabel, which is a bridge between the Isabelle language and Scala, written by Lars Seppel, uses Coursier. Tori, which is a Jupyter kernel for Spark, uses Coursier to handle dependencies. Tori, which is part of the Apache incubator. Jupyter Scala that I authored also uses Coursier, and Scala Fiddle, which is a web UI to run Scala code, also uses Coursier to add dependencies on the fly. So the component of Coursier that is the most used is I think it's SBT plugin. So at first it was written. So here, before we see it first downloading a few metadata, then a bunch of jars. Initially it was written to to just check that the library was working fine. Then it quickly becomes the main driver for its adoption, and gaining more users via it. It allowed to unveil lots of missing features in Coursier, which were added in the meantime. And so basically that somehow postponed the 1.0 release of Coursier, but I'm concerned that it will the 1.0 final will be released in a few weeks. So yeah, the SBT plugin relies on the cache of Coursier. So basically, this cache has no global locks. At least, I mean, when you use the SBT plugin, it doesn't enforce. It doesn't. Coursier doesn't require any kind of global locks, but nonetheless, sometimes, depending on the keys of SBT that we use, we can run into some global locks. But I mean, Coursier doesn't enforce any of them. Also, it has it understands an offline mode. That is, Coursier just uses some time to live, and so basically, just by setting the time to live to a large value, we can go offline. And also, we can note that the cache of Coursier doesn't follow exactly the same. Doesn't have the same kind of path than the one under IV cache. That is, Coursier just basically mimics the URLs it puts in cache in its own path. That is, for example, this is the path of the Scala library in the Coursier cache. Yeah, and one question that arose is some people propose that the Coursier cache followed the XDG convention under Linux or OS specific conventions to put the cache. So this is still an open question, and opinions are welcome on that point. So a last big component of Coursier is its launcher. So this is basically a command line tool that allows to launch simple applications. That is, we can launch, for example, Scala format via this command, or we can launch Ammonite via this one. And what this does is this fetches the class path of these commands, and this just throws them in the class path and launches that. So basically, what this pushes us to do is we can publish applications as simple libraries, and then just use the launcher of Coursier to launch the applications this way. That way we don't have to, to create assemblies or to publish applications via Tor archives, and then we having to distribute them, when you can just publish things like libraries and launch them this way. Currently, milestones are being raised. It already has 12 contributors, and missing features are getting added along the way, and hopefully 1.0 is around the corner. So now I'd like to quickly talk about the applications that can be built on top of that. I just show you just before how Coursier could launch applications made of dependencies, and so that was something like this. There are actually, this is a bit cumbersome to type. That is, we have to type an organization, a model name, and a version. There are actually there would be more straightforward ways to do that. And one of them would be using the Scala Index. So this is a bit experimental. Currently, all of this is in a PR on the Coursier, on the GitHub of Coursier. But basically, what this PR allows is just launching an application via this kind of command. That is, here we just give a name to Coursier launch, and what Coursier launch does it looks up through the Scala Index for this name, and the Scala Index knows the actual GitHub repositories of this name. It knows the corresponding dependencies, and that way, coursier can get the corresponding dependencies of that and just launch them. So that allows to easily launch an application just out of its name. So another cool application which is on the same PR is when we add the class path of the applications launched this way are computed on the fly, we can also on the fly substitute some jars for others. That is, for example, we can swap the mainline Scala jars by the ones from Typelevel. And that way, for example, this command allows to launch Harmonite with by substituting the mainline Scala by the one from Typelevel. And that way we launch Harmonite with literal types enabled or with the various fixes from Typelevel Scala. A last big application is, just before I showed you how to run applications locally. Now, if I just substitute Spark Summit to launch, we actually get a way to launch Spark applications. That is, so here basically, I published a Spark application on a repository, let's say this one. Now I call Spark Summit of this job, and coursier enables to launch this application via Spark. So now we must add a few options for Spark. That is, after 2 hyphens, we add options for Spark Summit. So people who use Spark Summit should know them. We specify the number of machines we want, etc. And after 2 hyphens again, we can add arguments for our application. And that way, coursier Spark Summit does all the job from here. That is, so when we launch a Spark application, basically the usual way, three class paths are involved. That is, we basically have our application class path here. We have 2 class paths that come from the Spark distribution here, and coursier Spark Summit actually handles all of them transparently. That is, we don't have to manually manage this one, don't have to manually manage a Spark distribution, and so that allows to launch Spark applications in a really straightforward way without having to manage assemblies or Spark distributions. So now, so what I showed you just before is in the current master of coursier. It's not. It's really experimental. It's in use at my company, but it's still a bit rough around the edges. Now, other features that could land in coursier after 1.0 are, for example, hot rewriting. That is, when we launch an application, it can be a web server using, let's say, HTTP4S or Finch, which don't handle hot rewriting natively. And but if we launch them via coursier, coursier could actually handle the hot rewriting part. That is, it could, when we launch an application this way, it could watch the corresponding jars that are either jars in IV local or jars from snapshot repositories. And if coursier sees that one of them changed, it can interrupt the web server and launch it again. So that allows to add hot rewriting to libraries that are not already under it. Also, another thing that would be nice to have is being able to launch SBT via coursier. It can't right now because SBT, it's not that straightforward to launch. There's a whole bunch of logic in it, but it's something that, in my opinion, is really rich, and it would be really cool to be able to do that. That is to have coursier download the class path of SBT in parallel, etc. because it can be quite painful currently. Also, among the changes that could happen after 1.0 are it could get a person API that is, for now, its API is a bit rough, it's a bit low level, and to be nice, some user asked for a person API to be able to more easily get a few dependencies. Also, for now it uses Scala concurrent, but it could switch to either FS2 or cats plus manix in the future. Okay, so that's it. So this is its website, and if you have questions, okay, I'm not sure. Yeah. I repeat. Yeah.
So I'm interested in. I have a library that needs to do for some other purposes. Actually, using for the Basel build system.
Yeah.
Dependency resolution, because it works very differently than it does in SPT. And currently, I'm using Aether to do some crawling, to do some resolution.
Yeah.
Is it super easy to how pluggable is the cache? Because in this example, I don't want to use some user shared cache. For those kinds of resolutions, if I wanted to use Coursier as a library to do this resolution instead of Aether.
You mean just replace Aether by Coursier? Or
exactly. And I want to be able to control the caching directory so I don't...
Sure. You can totally control the cache. It's by default, it uses something... Yeah, sorry. So the question was, can we, in Basel, could we replace Aether by Coursier? And in particular, can we specify the cache directory of it? So the answer is yes. It's illustrated a bit in the README, and you can also, for example, if you're using Coursier from the command line, you can set the Coursier cache environment variable, and that it would automatically switch to it. But it's also possible via the API. I could show you. Okay. Another question? Okay, so thanks for your attention.